Math 1343, Week 8, Video 3, Calculating Expected Counts for a Goodness of Fit Test. In the previous video, we described how to state the hypotheses for a goodness of fit test, and our next move is to work towards building evidence from our sample as to whether or not it supports what our claim about the population is. And our first move is to calculate what are called expected counts. Now there's another phrase for expected count. Expected count or expected value. I actually prefer the phrase expected value. I'm just using the phrase expected count to be consistent with the optional textbook for my class. But I'm going to use expected value because its abbreviation EV is a very common abbreviation for expected count or expected value. An expected count, and I should start this by saying an expected count. An expected count is the, it is the value of a variable you would expect based on sample size and claimed population proportions. What do I mean by all that? An expected count or expected value, or EV, is the value of a variable you would expect based on sample size and claimed population proportions. In this case, we have a sample size of 250. So let's start with that. We have our sample size of 250. What would we expect the number of sick days on Monday to be if the population claim were correct? Well, we have a proportion, a claim proportion of sick days used on Monday is 25%. So if we expect 25% of the sick days to be used on Monday, and there was a total of 250 sick days, how many we would expect? How many would we expect? Therefore, we would expect, and I'm going to use EV for expected value, we would expect an expected value of 250 times 0.25. In other words, 25% of 250. Well, it just so happens that 25% of 250 is 62.5. And obviously we can't have 62 and a half sick days used on Monday, but that's what we would expect out of a sample size of 250 if we assume 25% of those were used on Monday. Now notice that that is not what we observed. What we observed in the sample of 250 was actually 50. So notice we observed a value or a count of, for observed value, I'm going to use capital OV. We observed 50 for Monday. So what we have for Monday is what we observed versus what we expected. So let's go ahead and start a table, and we're also going to create a very simple formula. Our table is going to consist of days, observed values, and expected values. On Monday, we observed 50. But according to our population claim, we would have expected 62.5. Let's do the same thing for the rest of the days. Tuesday, Wednesday, Thursday. Thursday, and Friday. The observed values are easy. We were given all of those. This is what we observed from our sample. We observed 50 sick days on Tuesday, 30 sick days on Wednesday, 40 sick days on Thursday, and 80 sick days on Friday. But how would we calculate the expected values? Well, what we expected on those days of the week were 25%, 15%, 15%, 15%, and 30% respectively. So out of the 250, we can calculate the expected values the same way we did for Monday. We would just have to multiply by a different proportion. So for example, for Tuesday, our expected value would be, out of the 250 sick days used, we expect 15% of them to be on Tuesday. So what is 15% of 250? 37.5. If the claim about the population was correct, that's what we would expect on average, the number of sick days to be used on Tuesdays. And notice that's less than what we actually observed. Now, luckily, our hypothesized proportions are the same for Tuesday, Wednesday, and Thursday, which means the calculation for the expected value to be the same. So each of these we expect 37.5. And some are closer than others. For example, on Thursday, it's pretty close. It's only off by 2.5 days. But what about Friday? On Friday, what would our expected value be? Well, we expect 30% of the 250 sick days to be used on Friday. So it would be 250 times 0.30, which is exactly 75. And that's not too far off what we observed. Remember, the gist of hypothesis testing is samples will disagree with claims about populations. That's just the nature of sampling. But will it disagree by too much to accept our claim as being true, or will it deviate far enough to say, you know, this is too far away from what you claimed about the population, so we're going to reject what you said. But in short, to calculate an expected value, it's really easy. To calculate an expected value, the expected value for a value of a categorical variable, also known as a qualitative variable. Just a reminder, a quantitative variable is a variable that measures a quantity. How tall are you? How many sick days are used on a particular day? How many pets do you have? How many times have you been married? Stuff like that. Whereas a categorical or a qualitative variable measures a quality. What day were you used? Monday, Tuesday, Wednesday, Thursday, Friday. And typically when we have a categorical variable, we measure it with a percent. But the expected value for a value of a categorical variable, expected value for this Monday, for this Tuesday, for Wednesday, Thursday, and Friday, is expected value equals sample size times proportion. Real simple formula. Multiply the sample size times the proportion to get the value you would expect for that value of the category. In this case, the category is day of the week. The value Monday, we expect 62.5 sick days. That's not what we observed. All right, so pretty easy calculation, just sample size times proportion.